your screens. All right. So I'm hoping that right now, oh, not yet. Now you should be able to see it. You guys should be seeing my little drawing board that I have. Let me see if I can get, I like to be able to see it myself so I can see what's going on. So as I said, today we're going to talk about something called isometric drawing. And this is in chapter 7 of your book. And it's a really short chapter, but it's filled with really good information. And when I think about isometric drawings, I think about the sketches that you make when you're working with a client or when you're working with people in your office and y'all are talking about designs and you're trying to make a point or something, and so you grab a sheet of paper and you sketch something up real quick. Now, we also draw them in AutoCAD, but first I wanted to kind of show you a little bit about the theory of isometric drawing just using a drawing board. So over here you can see, you might want to set your screen to full screen if you want. So I'm going to move over here to this drawing board. And so as I said, what we're working on today are called isometric drawings. All right. And what an isometric drawing does, if you're thinking about it in a real simple term, is this. It's a type of pictorial drawing where the object that you're drawing is going to look like it's three-dimensional, even though it's not really three-dimensional. So I'm just going to get started on something like this right here to give you an idea of what an isometric drawing might look like. Now, I'm using a straight edge, and normally I don't use a straight edge when I do these, and I'm going to show you why I'm using a straight edge, though. The triangle that I'm using right here is called a 30, 60, 90-degree triangle, and those are the three angles that I have. Isometric drawings, what you want to do when you make an isometric drawing is you're going to draw your lines at a 30-degree angle relative to the horizon, like that. And so if I'm going to go in this direction over here, I would flip my triangle around. Now, usually, like I was saying, I don't have a triangle when I do this. I'm just sketching, like I said, maybe for a client or something. And so what I do when I'm doing freehand sketches, what you need to know is that vertical lines just go straight up and down. They're vertical. But horizontal lines, you want to go at a 30-degree angle. So, I'm just kind of sketching here. This is going to not going to look as good because I have some of these perfectly drawn straight lines in here. But this is an example of, what an isometric drawing looks like right there. Okay. Now, of course, we have been used to drawing front view and a side view and a top view of the same thing, right? And then putting our 45-degree line in there and projecting information. This is what an isometric would look like of that object. So when you're sketching for a client and you're trying to get your idea out there, sometimes it's hard for people to understand when you're just trying to put it into words. And so if you can quickly know how to sketch something like this, it's really helpful. So I want to point out over here, again, this angle is at 30 degrees. In AutoCAD, we actually have a little switch we're going to turn on, and AutoCAD will draw lines perfectly at 30 degrees. We won't have to worry about that. So the other thing with isometric drawings, the characteristic of isometric drawings is this. If you have a hole in this part right here, it's going to appear as an ellipse. All right, so I'm going to drill a hole right down through the top of this guy, and I'll show you what that ellipse would look like. Okay, does that look like a hole going straight down? Yeah, and so that's how you draw it, and there's a way that you orient those ellipses, and I'm going to show you a trick for doing that as well. But if we had a hole on this side, the ellipse would look like that, and you can see that it's tilted compared to this ellipse right there. And if we drilled a hole through this side over here, that ellipse would also be tilted. And there's actually a rule for the tilt on these ellipses, and the tilt on that guy is at 60 degrees, even though the lines are running at 30 degrees. Same thing over here, that the angle that ellipse is tilting is at 60 degrees versus the lines are running at 30 degrees. Now look at the ellipse though up here in the top, and what is the angle that it's running at? Well, it does not have an angle. What you do is you want to draw the ellipse at a 0 degree angle. And when I say 0 degrees and orient these things, I want to show you something about an ellipse. Whenever you have an ellipse, the longest line that you could draw from one side of that ellipse to the other is called the major axis. Oh, axis, like that, right? And so really what we're orienting is the major axis of this ellipse. And so whenever we have an ellipse on a horizontal plane, and this is a horizontal plane right here, think of it, it's like parallel to the ground. This would also be a horizontal plane. So if we had a couple of holes in this, we would orient those ellipses, the major axis, at 0 degrees. This plane over here is a vertical plane, and AutoCAD refers to this plane as an iso-left plane. And on an iso-left plane, the major axis of your ellipse runs at 60 degrees, and it runs up and toward the left like that. And this plane over here on this side, because it's on the right side, this is actually what we would call a vertical plane, and this is a horizontal plane up here. This plane right here is called, by AutoCAD anyway, an iso-right plane. Now, drafters didn't make up these words. Drafters use different terminology for that forever, but when AutoCAD came along, they made up their own words, and they decided to call this iso-left and this iso-right, and this they actually call, in AutoCAD terms, iso-top. And the way you change your ellipse orientation in AutoCAD is when you're drawing an ellipse, by pressing F5 on your keyboard, you can toggle the ellipse so it will change from a horizontal ellipse to a right vertical or a left vertical ellipse. Now, I called this plane right here a right vertical plane, and I called this plane over here a left vertical plane. That's the correct terminology for it, but like I said, when AutoCAD came along, they didn't know that, so they called it iso-left, iso-right, and iso-top. So that's kind of changing the terminology of industry. So I hate it when software drives the technology, right? I think it ought to be the other way around. I think users ought to drive what the software does, but I'll let that go for right now. So does everybody see the concept of that horizontal lines run at 30 degrees, vertical lines run straight up and down, and ellipses are what are used to represent holes or circles, okay? So what I recommend doing is drawing, if you're a beginner, I recommend just sitting around and sketching this cube right there. So this would be at 30 degrees, and this would be at 30 degrees, okay? And then these sides will all be parallel to those 30 degrees, and these will just be vertical. And so when I was beginning out, and I knew I needed to sketch, because designers have to be able to sketch, I would just draw this cube over and over. But I'm going to show you something else I would add to that cube. Now, I'm actually going to draw a little bit bigger cube just to make my point here. So draw this a little bit bigger. And remember, this has to be at 30 degrees. And so you want this and this to be parallel, and this line to be parallel to each other. So I would sit in meetings and things like that, and just to pass the time while I was listening to what was going on in the meeting, I would sketch this cube, and then I would sketch an ellipse in there on the top surface, like that. And I would practice, making sure that I understood that the major axis of that ellipse is at 0 degrees. And then over here on the side, I would imagine that I had a line connected from corner to corner, and I would draw an ellipse like that over there, and I would draw another ellipse over here, and I would orient the major axes. And so remember, this one's at 60 degrees, major axis. This is at 60 degrees. This line right here is at 30 degrees. This line is at 30 degrees. This major axis up here is at 0 degrees. All right. Now, other things that you will sketch, pardon me, and why I think this is so important to get to where you can just sketch that in your sleep is this. You could be working on a job where you have to draw something that has a cylindrical shape. So I'll draw, let's say I've got an upright cylinder. Well, first I would start by sketching that ellipse right there, and then I would go out here to the tangency and draw 2 lines down like that, and then I would draw another ellipse like this right here. And so if I were drawing vertical cylinders, this one would actually be hidden back here. And so imagine that the center axis of that cylinder runs north and south like that right there. If the cylinder were laying on its side, I would draw the cylinder at 60 degrees, the major axis at 60, and then I would draw this like the back of the hidden line right there. And so my center axis is running through like this. And vice versa, if I'm drawing where an ellipse is running in this direction, my major axis is going to be there at 60 degrees. My center axis is coming out like that. So this is something that if you guys want to go into the field and really be designers and really be architects and you're going to have to learn to sketch. That's just all there is to it. But when you combine good sketching techniques with good freehand lettering, you actually will start to look like you are a designer and you know what in the heck you're doing. Okay, it's really important that you practice this stuff. Now I'll show you another variation on this theme over here. So let's say that I've got an ellipse that looks like that. So this would be a horizontal ellipse. The center line of that ellipse actually runs along 30-degree angles like that right there. But I want you to imagine that I've got another smaller ellipse that comes down out of that. So this would also be, one of those horizontal ellipses. And so I also would have a center line running through this thing in that direction as well, right there. Okay, so when you add center lines to this stuff and you add center axes and everything, your sketches start to look a lot better. Now, the thing that I haven't covered is, but what do you do when you have an inclined surface? So I want you to imagine that, let me draw something over here. Imagine that the front view of an object looks like this right there. And so we know we're going to have an inclined line or inclined plane. And so let's say that the right side view of that would look like this right here. And this is your inclined plane. I'll put an eye on it so we can see what it is. How do you deal with this angle in an isometric drawing? Well, I'm going to show you how to do it. I'm going to label this length right here as A, and I'm going to label this side as B, and I'm going to label this distance right there as C, and this distance right here as D, okay? And then I'm going to transfer those lengths over to an isometric drawing. So I'm going to draw this over here. So I'm going to start at a corner, and I'm going to put length A in, like that right there. And then I'm going to draw straight up for B. And then I'm going to take C, and I'm going to run it at a 30-degree angle. This is C. And then I'm going to come over here to D, and I'm going to draw it straight up and label it. And you can see where I'm going with this is that then I'm going to connect the dots. And that gives me the angle of my inclined plane. So I can't measure that angle using a protractor or anything. I have to actually construct the endpoints for the angle. And so in the assignments that you're going to do, you will be doing some of that construction where you're trying to figure out where's the start and end point for inclined planes. Now to finish this, let's say that we take this width right here and we call it E. So that would be the distance from here to here. If I add distance E in at 30 degrees, so this distance right here is E, and I go the distance of E here, and then I connect that right there, and then I connect that. Looks like I'm a little bit short right up in here. Okay, this is inclined plane I right there. Okay, so there's things you're going to be dealing with, and those are like your your normal surfaces, which are like left vertical, right vertical, and then you have horizontal. So this would be a right vertical in here. You're going to be dealing with holes and cylinders, and you have to remember the difference between the 30 degree and the 60 degree for the major axes on the left or the right, like these guys. And then keep in mind that anything that's on an iso top or a horizontal plane runs at 0 degrees. And then the last thing you have to deal with isometric drawing is what do you do if you have inclined planes? And so where this kind, the inclined plane thing, you may think, well, I'm going to go into architecture. I'm not going to need this stuff. You'll need it more if you go into architecture. You're always going to be sketching. Pardon me. You're always going to be sketching for a client. And so if you imagine just something really simple like a house, and you're sketching for your client, and you want to make a sketch for them of that thing right there. Well, these roofs, those are inclined planes. So how are you going to draw that? Well, if you do that thing I was showing you where you label those links in there, and then let's say we go A, and this would be C, and this would be B, and then we take this distance from here all the way straight up right there, and we transfer that distance to here, and then we connect those lines. This was going to run at 30 degrees right here, and you can see how we go from this over here to where we start to get an isometric sketch for a client. Now if this had a door in it like that, we would transfer the distance from the edge to the side of the door, and then from the edge to the side of the other door, and we would draw those vertically, but then the top of the door would run at a 30 degree angle like that one right there. Okay, but what if we had a vent up here? We had an attic vent and it was round in the front view. Okay, so what you have to do, if you look at this or you look at this, you say, okay, which plane would my attic vent hit on? Well, it's going to hit on this plane here, and that is an iso right plane, and you can see that your 60 degree, the direction of your 60 degree angle there, and so you would come in here and you would draw that ellipse like that. Now if you were drawing an attic vent, a lot of times what it actually would look like is something like that, and then it has the vents. The vents are going to run actually at 30 degrees like that. So you could add those in, and then maybe add a few things over here to show kind of the angle of the plane. And there you go. There's the architectural isometric sketches. Anybody have any questions they want to ask about that? Because I'm going to switch over now to AutoCAD. So let me click on AutoCAD, and all right, so hopefully you're seeing my screen again right now. I think you are. This is an example of an isometric drawing, and this is the first isometric that you're going to draw is this guy right here. This is called the T connector, T-E-E connector. It's a T-shaped connector. It's got a couple of holes in it. It has an inclined plane, so you're going to have to deal with that angle in the inclined plane. The video for this in Blackboard for Chapter 7 is going to walk you through this, and it's pretty simple actually to draw this, and I want to show you what the construction looks like. The first thing we do is just draw two lines like this right here, and then we draw some ellipses, and then we connect the quadrants of those ellipses and we do some trimming, and then we construct that angle that we have right there. And once we trim all that out, and essentially we construct this front surface right here. Then we copy that front surface back along a 30-degree angle, 1 inch. That's the thickness of this thing. So it's pretty simple to do, but you have to watch the video probably to do it, although the textbook in Chapter 7 gives you step-by-step directions for how to draw this thing. Now, I want to show you a couple of things. Let me see if I can move this out of the way. So how do you get into isometric snap and grid? Well, you see this tool right here down there on your status bar? You have to pick on that and turn it on. So look at my cursor right now. You see how it's just a regular X and Y cursor. If I come down here and I pick on that tool right there that's called ISO Draft, I'm going to pick on that and look what happens. Now, if I draw a line and I snap, I'm going to be drawing along a 30-degree angle. Either I'll be horizontal, vertical, or I'll be perfectly at 30 degrees. Now, sometimes it's better, I think, when you're drawing these guys to, instead of using your polar tracking, go ahead and use Ortho Mode. And Ortho is F8. So if I press F8, and what that does, it locks me in. I can go horizontally and vertically, or I can I'm locked into going 30 degrees. All right. But what if I wanted to go 30 degrees up and to the left? What I have to do is press F5 on the keyboard, and then that changes the orientation of things. So by pressing F5, I can change the directions that I can go with a line when I'm in the ISO snap mode. So whenever you start your new drawing, you're going to open up a prototype drawing and you're going to turn on this tool right here, ISO Draft. Now, if ISO Draft is not on your status bar, or if you're ever missing something that you need on your status bar, remember, go over here to these 3 lines right there and pick on that. And then that's going to give you all the tools that you can add to your status bar down here. And so you want to find this guy right here, Isometric Drafting, and make sure that there's a check by it so that you'll have that tool down there. You'll also want to have Ortho Mode and Polar Tracking, which are those 2 guys. You should have those already. Usually I don't have my grid on, and I sure don't have snap on. So, you know, we have those on, but I'm not a big fan of those guys. You know, so I want to make sure I turn my grid off. So we're going to be starting this drawing kind of near our UCS. I think it'll give you some coordinates to get started, but you can move it around wherever you need to. All right, so I'm going to just draw a couple of lines. So I got in my line command. I'm going to press F8 and turn ortho on, and then I'm going to press F5. Okay, and I'm going to start my line command, and it looks like I've got ortho off. So I'm going to pick right here. I'm going to go in this direction. I'm going to type 3 and press enter. Okay, now I want to go straight up, but I can't. And if I can't go straight up, let me zoom in a little bit. What I want to do is press F5, and that toggles me where I can go straight up. I'm going to go straight up here. I'm going to type 3 and press enter, and then I'm going to come down and to the left and type 3 and press enter, and then I'm going to go back to my start point like that. So there's a plane drawn isometrically. If I start my line command again and now I want to go back in the opposite direction, I have to press F5 and toggle in this direction. So I'm going to go in that direction and type 3 and press enter. I'm going to go straight up, type 3 and press enter, and then I'm going to come to right there and pick, and then I'll press escape. So you can see I'm starting to create a what looks like a 3-dimensional cube. It's not 3-dimensional, it just looks like it is. This is not a 3D model. Okay, so one thing you could do at that point is you could use your copy command, pick on copy, and it says select objects, pick that guy and press enter. And when it says specify a base point, pick right there and move it, copy it to there. And then I could also do a copy, and I could pick this guy and press enter, and for the base point I could pick at that end point and move it to that endpoint right there. All right. Now, let's say that I want to put an ellipse in here. I want to show you I'm going to show you how to do the ellipses, and then I'll turn you loose to draw on this. So I'm going to draw a line from this corner to this corner here, and I'm going to use that as a construction line. I'm going to draw an ellipse at the midpoint of that line right there. So to draw an ellipse, you'll go over here and you need to find the ellipse tool, which is right over here, or you can get it right up here. Okay. And the ellipse tool, hang on for just a second, let me get on this guy over here. So if you pick on ellipse, here's what's going to be important to do. You pick ellipse, and then look at your command line down here. You have to tell AutoCAD that you're doing an isometric drawing. So you have to pick on the word ISO circle, or you just type I and enter. Either one will work. Remember that in AutoCAD, when there's words down here, all you have to do is type the capitalized letter and press enter, and you can get into it. All right, so I'm going to start the command again. So I'm going to go to ellipse. I'm going to pick ISO circle. It says, where's the center of the ISO circle? That's going to be right there. Now I'll start to move my mouse a little bit, and does that look right? It doesn't to me. The orientation should be at a 0-degree angle. So how do I get to that? I press F5. All right, now it looks like it's going to be right. And right now it's asking me down here, specify the radius, or if you pick on diameter right down here, or type D and enter, pick on diameter. I'm going to type 1 and press enter, and there you go. It just draws that, and it's oriented correctly. Now I'm going to draw another line from this corner to this corner, and I'm going to draw another line from this corner here to this corner up here. And I'm going to draw ellipses on those just to walk you through it real quick. So you pick on ellipse, you choose ISO circle. If you don't choose ISO circle, things don't work right. It asks you for the center point, snap right there. You can see that guy is not oriented at a 60-degree angle. So you press F5. That looks correct right there. And this time I'm going to keep it at radius, but I'm going to type a radius of 1 and press enter. That's going to give me a 2-inch ellipse like that. And I can go back to my ellipse command. Remember, all you have to do actually is just press enter, and AutoCAD will come back to its last command. Pick on ISO circle. I'm going to snap right there. I can see that's not oriented correctly, so you press F5. And for the radius, I'm going to type 1 and press enter. That's going to give me a 2-inch diameter. And then I could come in here and I could delete those guys out, and you can see what my isometric cube with holes cut through it, and everything's oriented correctly. So the workflow is going to be to open the prototype drawing up in Chapter 7, and that's all in Blackboard for you. And so let me give you a page on this guy. This starts on page 330. And it tells you to open the Imperial prototype. Well, that's in Blackboard. You don't need to go out and download the Imperial Blackboard. And it says to set your units to decimal, and to save the prototype as T-connector. And then in step C, it says pick on the snap type and set that to isometric snap and turn ortho on. Step 2 says create an isometric layer with default line weight. And then step 3 starts giving you the steps. Now you can use the steps that are on page 330, 331, 32, and 333 if you want to, or you can watch the video. Either one will work. Where it gets a little tricky, pardon me, is on page 332, down there in step 12 and 13. We actually add fillets to the corners, and so this is the fillet here, but there's something weird about the way AutoCAD does fillets is the fillet command doesn't work. So what you have to do is actually draw an ellipse in here and trim the ellipse out. And so the video and the book will show you how to draw that ellipse and trim it out. So don't try to use your Fillet command. It won't work. I mean, it'll do something weird. I'll give you an example. If you pick on Fillet and you choose radius, and let's say I type 0.5 for my radius, and I enter, and I pick here, and I pick here, it draws a fillet, but the problem is it drew that fillet as a circle. It's a round fillet and not an elliptical fillet, and it should be an elliptical fillet, right? And that's why it's not going to be correct. So instead, what you would need, let me just move this guy over here. And press F8. What I need is to construct an ellipse right in there like that, and then trim these lines out. Now I just eyeballed that, so it's probably not going to trim very well. Yeah, it trimmed that entire line. But you can see that if I had a line from here to there. Okay, see, so what I need is an elliptical fillet and not a circular fillet. And the fillet command gives you circular fillets. This is something, I'm one of the AutoCAD beta testers, and every year I tell them you need to fix the fillet command so that when you're in the isometric snap mode like we are right now, that it draws elliptical fillets and not round fillets. And they never listen to me, but that's okay. I mean, for $5,000 software program, what do you expect? Okay. So there you go. There's kind of the overview of everything. So let's go to Blackboard now. And I think I'll have to drag this over to here. Okay, Blackboard's going to make me log in again. Let me do that. Oh, come on, don't do that to me. Sorry about the delay here. So we are 06415, that's our section number. So when you go to the opening page, you're going to go to chapter 7. So let me turn it on for you so you'll be able to see it. So when you go to chapter 7 and you click on it, it's going to take you over here, and there is a PDF on drawing isometric drawings that pretty much covers what's in chapter 7. And so almost everything I talked about today is covered there in chapter 7, but I wanted to give you a preview of it before you read it or anything like that. So we don't have a video of it, but like I said, I'll post this video. The required assignments are to draw projects 7.1 and 7.2. And 7.1 is the T-connector, and 7.2 I'll get to in just a second. But just to show you, when you pick on assignment 1, project 7.1, it tells you to watch this video on drawing the T-connector, and here is your imperial prototype drawing that you can open and save as T-connector, and then you watch this video, and then it says to print this, in my case as a PDF file, and put your name in the file, and then send it to me, email it to me like you've done before. As soon as you're done with that one shouldn't take you very long to do. We want you to pick on project 7.2. Now on this one, you don't have to open a prototype, because you're going to open up your old friend, the tool holder project. So you last had the tool holder open last week when you were putting some dimensions on it. So you're going to open the tool holder and make a new layer named isometric. And you're going to draw an isometric view of the tool holder in the upper right corner of that page. And so we have a video showing you how to do that. So I'm going to click on AutoCAD real quick and show you what that looks like when you're done. Let me zoom out. Yours will look like that when you're finished, when you draw the isometric. And then you will print it and send it to me as a PDF. So all of this stuff over here, the views and the dimensions and the notes, you have already drawn if you finish this project in chapter 5. So all you're going to be doing is adding this to this drawing And then when we go over here and we see it in paper space, you will see your isometric right up there. And you will print this as a PDF and send it to me. And all I'll be grading is this part right here. And because hopefully you've already submitted your dimensions and I've given you a grade for this project with dimensions and notes, now all I want to see is, can you draw that isometric? Now some of you are going to probably blaze through this pretty fast and you may want some more to do. So I'm going to give you the option of actually an extra point project. That would be to draw it backward like that. So the steps in the video show you how to draw it like this, and also the steps in the book show you how to draw it like that. But if you want to try it, see if you can draw it backward. Now, if you look on page 334 of your book, you're going to see it laid out step by step, starting on page 334 and ending at the bottom of page 336. Okay, so there are your options, and for if you want to try to draw it on your own using the directions in the book, you can. Just to give you an idea, the way the book has you start, and also the video, is to draw this green box right here. And that box is 7 inches long, and it's 2.5 inches wide in this direction right here, and it's 2.75 inches tall. And so you start by drawing this green box, and we call that a bounding box, B-O-U-N-D-I-N-G, bounding box. And what a bounding box will do, it would completely enclose the object that it represents as the bounding box. Okay, so by drawing the bounding box, you can actually use it to construct this guy inside the bounding box, and it helps you out. And one of the ways it can help you out is like this slot right here is cut in, let's see, looks like it's cut in 1.5 inches from this edge right here. And so what you could do is you could use your copy command, and you could pick on the bounding box line and enter, and you could pick a base point. Now you can pick out here in space if you want for your base point. It's like a handle, but then you want to make sure that ortho is on, so you can move, exactly at 30 degrees, and you type 1.5 and press enter, and there you go. There's that cutout, and all you'd have to do is go in here and do a trim and trim these guys out, and you would have the start of that cutout. So the bounding box gives you some geometry that you can copy and move and trim as you construct this view.